Hello guys, welcome back to Cao 2025. Today we're going to learn how to use Wan 2.2 image to video using the Kijai Wan Video Wrapper. Since I've already explained many of the core concepts in my previous text to video, this time I'm going to get straight to the point. If you need the details, refer to the link in the video description for all the models and resources. Go to your manager, click Install Custom Nodes and search for Kijaiwan. Hit Install if you already have it. Hit Update like I'm doing here to make sure you have the latest speed boosts. Wait for it to finish, then click Restart. Once it's back up, just refresh your browser. Easy. Next is for getting all the model.
First, let's download the necessary models. You can find all the links in the video description. We are using the Wan 2.2 model GGUF. Access the HuggingFace link. Wan 2.2 uses two sequential models, high noise and low noise. You need both GGUF files. I recommend choosing a quantization based on your VRam. I'm downloading Q5KS for both. Place both GGUF files in your comfy UI/models/diffusion models folder. Remember, they run sequentially, so you only need VRam to accommodate the single largest model. For the VAE model, use the same VAE as Wan 2.1. Download it if you don't have it and save it in comfy UI/models/VAE. To dramatically increase speed, we need the Light 2V LoRA. The link is in the description. Save this LoRA model in comfy UI/models/LoRAs. I'm using rank 64, and for text encoders, we'll use the Wan 2.1 encoders. Download the UMT5XXLPF16.SageAttention and save it to comfy UI/models/text encoders.
First step, we add the model loader for the high noise stage. Select your T2V high noise model. For the settings, select FP16 fast. If you are using GGUF models like I am, make sure quantization is set to disabled to avoid conflicts. For attention mode, use SageAttention if you have it installed. It's a massive speed boost. If not, stick with SDPA. Now duplicate this node. In the second node, change the model to the T2V low noise model. This will be our refiner stage. If you have Triton installed, connect the Wan Video Torch compile setting node to both of these loaders for an extra speed boost. If you don't have Triton, you can simply skip this step. Next, we need to handle our memory. Add a Wan Video Block Swap node. This is what allows us to swap VRam with regular RAM so we don't crash. To apply it, add the Wan Video Set Block Swap node. You'll need two of these, one for the high noise model and one for the low noise model. Connect them up so both models can benefit from the memory saving. Now we use the Light X2V I2V low array to reduce our total steps. Add the Wan Video Select Low Array node and select your I2V low array. Add the Wan Video Set Low Array node to apply it. Important pro tip, just like in my last video, set the high noise low array weight to 3 to lock in the motion, but set the low noise weight to 1 to keep the details clean. Also, make sure Merge LoRAs is turned off. Apply this to both the high and low noise chains. Now let's add the Wan Video Sampler. Use an integer node for your steps and set it to 8. This makes it easy to sync with other nodes later. Add the Create CFG Schedule float list. Follow the settings you see on my screen. This ensures the first step uses CFG 2.0 to kickstart the prompt adherence. Set the scheduler to DPM++ SDE. For the end step, use another integer node and set it to 4, which is half of our total steps. For the image embeds, use the Wan Video Image to Video Encode node. I'm setting the frames to 81. Connect the Wan 2.1 VAE to this node. For the start image, I use a Resize Image V2 node connected to my Load Image node. This gives me full control over the video resolution. Finally, for text embeds, use the Wan Video Text Encode Cached node. Select your encoder, write your prompt, and the high noise setup is done. Now duplicate that sampler for the low noise stage. Connect the low noise model chain we built earlier. Use the same image embeds, text embeds, and total steps. Crucial change, set the CFG to a flat 1.0. Take the end step from the first sampler, which was 4, and plug it into the start step of this one. This ensures the second expert picks up exactly where the first one left off. To finish the workflow, add the Wan Video Decode and Video Combine nodes to see your result. Let's look at the clock. It took 11 minutes to produce this result. That is 4 minutes faster than using only the standard comfy UI core components. Even better, the second generation, once models are loaded, took only about 326 seconds. Compare that to the usual 8 to 10 minutes for core components, and you can see why this Kijai setup is a must-have. I also want to show you this side-by-side comparison. On the left is the standard CFG 1.0. On the right is my CFG 2.0 first step hack using Kijai. The comparison is proof using CFG 2 at the very first step creates a much more stable and accurate video. By combining Kijai's wrapper with Triton, SageAttention and block swapping, we've reduced process time, enhanced the quality and slashed VRam usage. That's it for today's guide. If you found these speed boosts and memory tips helpful, please like, comment and share this video with other creators. If you want to see more deep dives into Wan 2.2 and Comfy UI, make sure to hit that subscribe button to join the Cao 2025 community. All the examples generate using RTX 4060 Ti 16GB of VRam. Check the description for the workflow link, including the bonus upscaler and 60 FPS interpolation. Thanks for watching and I'll see you in the next one. Have a nice day and please subscribe.